Good morning, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm the host for today's series. We try in this particular series of webinars to include topics of interest in electrical safety and system design. And today, I think, is a very timely presentation because it deals with the virtual world that many of us are living in right now. Before I introduce our guest speakers, as we're in the habit of doing, I'd like to walk through a couple of poll questions. We appreciate your feedback and input. And the first question is, how many of your projects utilize a data-connected architecture? So whether you have data collection or monitoring or control is what we're kind of seeing feedback on. There's no liability, just strictly trying to get a feel for where the audience focus is. And I think it will help emphasize the material that's being presented once we kind of have the profile. Looks like we have a pretty good attendance today. We're about halfway to a quorum. We'll leave this open another 10 seconds. All right. So here how folks have weighed in on this. Pretty good distribution of participants. Thank you. Then the second question is, how important do you feel an integrated 24/7 thermal monitoring capability would be? Again, it's a little bit of a jump shift from where we normally describe stuff, but I think it's pretty important. And I thought our choices of answers is pretty widespread too. So again, your opinion and your feedback is valued. All right, let's leave this another 5 seconds. Good. Here's how folks have weighed in on this. All right, very interesting. And the third question is, would you accept a Bluetooth connection from a smartphone as a method to open or close a circuit breaker? This is fascinating to me, just in terms of the different facets that this opens up in the dialogue of electrical safety. So good chance to cover a wide variety of opinions here. And I do appreciate everybody's perspective on this. It may be different from mine. All right, looks like we have a quorum. Here's how people have weighed in on this. Again, fascinating question. And then finally, have you ever designed or utilized a microgrid system? And this actually comes up a lot. So I'll be curious to see what the audience disposition is. All right, let's give this another 10 seconds. All right, here's how people have weighed in on this. I do want to indicate, normally we take questions through the question box. If you would please, for today's presentation, because our presenters are widely spread geographically, would you use the chat box to enter your questions during the presentation? Now I'd like to introduce our guest presenters, Mr. Duke Dunsford and Jaime Gutierrez, and a fascinating take on today's world. So give me just a second to make sure we're sharing everything correctly. Jaime, you should be able to take over the presentation.
Thank you and good morning, everyone. My name is Jaime Gutierrez. I'm here also with one of my colleagues who's also on the line. Duke, do you want to say hi to everybody?
Yes, hello everyone. This is Duke Dunsford. Jaime and I are normally together, but we've got a little bit of a quarantine issue this week, so I'm at home. But Jaime and I will do our best to tell you a little bit about what we have in Nashville, Tennessee as part of what we do. We've got a very interesting facility which will help us address the topic today, I think in a timely way, as Jim has mentioned. Just real quickly, our agenda today, we're going to talk about a couple different things around the connected power distribution topic regarding outcome-driven designs based on prescriptive applications, utilizing connected power systems. We're going to talk about what a connected power system is, although I was very surprised to see many of you, or a majority of you even, are already using connected systems, so that's exciting. I was also very excited to hear about your interest in thermal monitoring. So we're going to show you an example of a connected thermal monitoring system, which you may find very interesting. We've also got some new technology around augmented reality, which brings some of this connectivity into the topics that we're discussing, so that'll be exciting as well. And we've got a brief discussion on microgrid today, and then we'll end the hour with a discussion about some predictive analytics that we can get through all of this connected technology. So that's our agenda here for the next few minutes. And Jaime, maybe you could introduce yourself, or I think the next slide here has a picture of both of us on it.
No, actually, the next slide is where we're diving right into our architectural example of modern communication systems. But I will do a quick introduction about myself. So, by myself, my name's Jaime Gutierrez. I've been with Schneider Electric for a number of years. Been always in power distribution, but now really helping out on a branch of Schneider Electric where we're really focused on how do we take connectivity to the next level? How do we make, really it's how do we leverage connectivity across all industry to really get what you're showing there as connected devices, right? And then all of these connected devices, where does that data go? How does it flow in the facility? We're going to show you in a little bit just one example of how that data can go to a PC, a server, something where the data can be processed or displayed. And then in many instances, this all has been is being done locally because of some concerns of data not going out to the cloud. But in some instances, there are opportunities where the data, once it gets to the cloud, can be further analyzed and processed to have further gains. So with that, because we're really focused on power distribution and leveraging connectivity, the things that we have to really be focused on when we're doing this is how do we enhance electrical safety through connectivity, through digital systems? How do we augment power availability, right? And how do we become more efficient? It's a huge difference to take activities, processing, report crunching, and go from something that takes me maybe a couple of days to do, to take that down to a couple hours, to maybe a couple of minutes. Have a quick overview of everything within my facility, and regardless of where I'm at, always have the right situational awareness to make sure that everything is designed correctly, running correctly, and is really optimized so that I can focus on other activities and not just trying to figure out what this data is telling me, right? Now, around that, Duke, you want to tackle this one, or you want me to keep on going with it?
Yeah, no, I'd be glad to. So one of the things we wanted to focus on today is to sort of help everybody think about what is the outcome that you're looking for when you're designing a distribution system. So Jaime showed you 3 of the key values, but then when you dig into that a little bit further, what considerations do you need to have when designing a system to get you to those end values? So a couple things we've got here just highlighted, and we're going to talk about this through our demonstrations today, but things like around communication. How are you communicating to devices? Do they communicate? What about data recording and time sampling of those devices? Is there some methodology there to record that data and to be able to do find issues inside the building based on time stamping? What about data processing? Go ahead.
I was going to add on, specifically with time stamping, how critical it is in today's modern systems to know exactly the sequence of events down to the millisecond level, right? And this is one of the considerations that a lot of people could sometimes neglect. And then you're later on in the life cycle of a project, and then come back and realize, we have all the right devices here, but we don't have the right time stamping to achieve the desired goals that we want to, right?
Yeah, exactly. So data processing, that has to be handled somewhere, whether that be in your building, in your facility, on the cloud, that sort of thing. Data interrogation between systems, interoperability. I know all of you that design systems have to deal with that constantly. Is everything interoperable correctly? Data quality, is your data reliable? Those sorts of things. And cybersecurity, that's a big one. We are very focused on cybersecurity with what we're doing at Schneider, but obviously everybody is immensely concerned with the cybersecurity area. So these are just some things that we point out here that to think about as you're designing a system. Is there a way to manage some of these key factors and features?
Correct.
How do you want to move on to the next slide here?
Of course. Now here's one example of everything that we just talked about. For example, if we're trying to look at how to maximize my assets performance, what are the things that I got to be looking at? And again, we're trying to leverage all the information, right, that we need: electrical measurements, environmental conditions, diagnostics of the devices, and then where is that data recorded, right? What's the metadata that we need to add on to that, like time synchronization? Again, we're putting everything together on the 6 considerations that Duke just mentioned. Next is, where's the data processed? In today's power distribution systems, there's a lot of existing power meters that can process data incredibly fast, incredibly accurate, and then share that data to another device. Maybe in other scenarios, the data could be processed at the server level, right? It's getting the information from the downstream devices, PLCs, relays, etc., and then doing some processing there. So it's really important to consider where the data is processed and how it needs to be shared to the next level. And in every single consideration, we always have to start thinking about early on, what are the outputs that we need to be looking at? I want live data, yes. I want events and alarms, yes. I want reports. Maybe that's not that critical, but again, I have the ability to do that. And this is just one example of how we have to consider all those things and take a set of inputs to produce a set of outputs, right? And here's an example, right? If we want to be doing trending on systems, on wages, right? Temperature, water, air, gas, electricity, steam, we can be looking at all those aspects through several devices today in industry, not just one. But if we have that data, how are we processing it? Do I want to be able to see it in a span of 6 months, 48 hours, 15 days, the last minute, right? We also need to be always looking at how fast I'm sampling, how fast am I time stamping, because I really want to have a good, accurate picture of everything within a facility. And those are the things that Duke and myself really focus on. We want to make sure that anything that we work with and everything that we're designing, we always start with the end in mind. This is what I want to achieve. What's all the inputs that are going to take me to that point, right? Duke,
I think it's important that I think it's important that we have actionable data. What we found sort of as an industry trend over the last few years is lots of people are able to collect data. Everybody collects data these days, but is that data actionable? Can you do something with it? And that's sort of like the end of the discussion of what do I do with all the data that I'm collecting to make my building better and more efficient, safer, all of those things that are important to us when we put a system together.
Correct. Thanks for that. And again, as a continuation to what we're looking at before, we're doing trending, but everything, the same conversation as more and more in industry start going to being greener, leaner, we have to be also starting to consider how are we, reducing consumption, being more efficient, being more green, and be able to report that out too. It's not a matter of just saying, yeah, we're doing that, but again, how can I take that data? How can it be actionable, to Duke's comment before, and really be, again, able to produce quality reports right away to say, look, here's our enhancements month over month, year over year, and now we can go on and pursue other projects that are going to help me enhance on my efficiency or my green KPIs. And so this is one of the examples that we've been able to see. Yeah,
if I can
go ahead.
interrupt you, let's save this till the end when we talk about the predictive analytics, unless you want to mention it now.
No. So I just wanted to look. I don't want to explain this just yet, but I want to at least start introducing the fact that this is one of the examples where we had all the data, but we had to do some really interesting processing to understand what that data was telling us. And I was just going to say that we were going to come back to this to really explain exactly what we're showing on the screen, to kind of put that together as, you know, a lot of data, a lot of processing, and what do we mean by actionable results? Okay, so let's flip over to our camera here at our lab so that we can, you know, go and talk now from, you know, the conceptual, the slide deck, to really look at one of our digital and connected power systems that we're managing. So this is an innovation lab that Duke is a customer experience manager for. I help maintain it and I help break it all the time. But I want to focus today, if we can slide our camera over here to the wall behind me, where we have what we call a power journey. In our power journey, yeah, we have all the components here to take us from medium voltage products. Again, everything's connected. We're not just worried about the gray box, but really how do we leverage data that goes from a piece of equipment to my PC. So we have medium voltage equipment, and then you would typically see right here a transformer to go from medium voltage down and step it down to low voltage. And then let's follow the wall. And now let's walk through our, for example, a typical installation would potentially have a 480 volt gear. Several breakers here now distributing power throughout the facility. And we're going to continue going. We have a set of emergency switch gear here, again, 480 volt gear, where we leverage an automatic throw over using a generator source that we have, as well as 2 utility sources. And we are able to do this now with an automatic transfer switch that we have back here. And then from there, we go from final distribution to final distribution with just a switchboard. And then that switchboard feeds several of the loads that we have in our facility here. For example, transformers, outlets, you know, power distribution panels. And so what we're doing here at every step, and I know that we just went through a quick journey from medium voltage, low voltage, and automatic throw-over equipment, is everything that you see behind here is, first off, it's really powered up. So it wouldn't be a good idea for me to open up the doors. Second, everything here is communicated and it's networked, because we want to make sure that everything here, we can get the data, leverage that, and do everything that we were talking about. We can look at the status of any assets that I have in here. We can look at examples of how my power quality is. And let's relocate here now to our low voltage switchgear so that we can talk about one of the examples of how things are connected. You know, everything today in industry, we're seeing more and more go into some type of communication platform or protocol, and right, we're adopting that, and we're trying to figure out what we can do with all this. And every single breaker that you see here, even down to the breakers at the switchboard level, are equipped with provisions to make them not only operate like they need to, but also to provide us data and information. I'm going to step to the side for 1 second, so I'm going to grab one quick example to show you how that could be done. And obviously, so now with circuit breakers, it's not just your thermomagnetics, right? But they also have control units, trip units that have cords and plugs where you can take data and bring this into a building management facility and then start leveraging that data to get enhanced results, actionable data. Now, how do you interface with this? Well, sometimes you're doing it from the front. There's also communication capabilities to do all of this through Bluetooth, or you can do this through Ethernet. It's really, again, how do you start your design with the end in mind? What is it that you're going to try to accomplish? Now, a lot of other things that could be communicating inside of equipment today are sensors. And we can look at sensors as small as what I have in my hand that can take information and tell us how hot joints inside of the equipment are. And once we know, for example, current that's flowing through a joint, how hot it is, you can start doing some interesting analytics and look at and say, well, if this is hotter than it normally is, but I haven't increased my load, could that be a potential for a loose joint somewhere in there? Or you can just do a lot of interesting things by leveraging connected architectures. What we're going to show you right now is a quick example of that on how we leverage those sensors that I just showed you inside of a switchgear. So today, a lot of people, when they're trying to figure out temperature information inside of cubicles, you're all familiar with IR windows, where every couple of months somebody will go and utilize that window with a thermal camera to look at that and see the temperature inside, see if there's any hot spots. What'll happen though is that after a week, a 2-month period, that information that you took was only a snapshot in time at one single moment. With now digital systems, connected architectures, you can be looking at information such as temperature and look at that 24/7 to really understand what's going on in your equipment. And one example is just like, for example, putting those sensors, they can be put anywhere, but you can put them close to your joints where you make your power connections. And then you start understanding if what your average temperature is. You can look at other type of environmental information, but then get all of that information, which I don't know if I mentioned this, but these sensors, and I've seen these from various vendors, are wireless. They get the information through Zigbee, through a concentrator. The concentrator now takes that data, knows exactly where each sensor is located. And imagine the other benefit here is that with sensors, you can access some cubicle locations, some compartments that in the past would have been really different or difficult to access because you couldn't really put a camera in there without being in the middle of potentially risky situation. Now sensors can be located anywhere to give you that information and see what's happening. Now, I like to use this joke quite often and say that in the past, if something were here, Duke would have called me and said, Jaime, go figure out where the problem is. Whereas today, I can just open up my computer or come up to the front of the equipment and let's focus in on this little HMI to show kind of where that data is being leveraged. All of the data that's coming from all the sensors that are in this cubicle, or actually lineup, can be displayed for somebody to just quickly see that. So we can have one line, for example, that shows a similar configuration of the equipment, but you can see what the highest temperature of any of the sensors that are in that structure. So in this one, the highest temperature of any of all the sensors I have in there is 41 degrees. This one's 51, this one's 39. But what I've done while we were looking at this is I turned on a resistor element so that I can highlight here underneath the HMI that we just had a pre-alarm come up. So a second ago, this light was green. Now we went and said, hey, something's happening. So let's try to figure out where the problem is. Again, in the past, Duke called me, said, Jaime, go figure this out. Today, I can go quickly to a piece of equipment and say, yeah, there's a problem. Got three structures to see. Well, let's quickly look at this one because this one has a little notification on it. My ambient temperature seems to be normal. Oh, look, there's a terminals, and in a matter of a minute, I quickly realized that in this section, looks like my phase B connection, my terminal, is about 25 degrees C higher than the other two. Left unchecked, over time, this builds up. And if you just notice, that just turned red. If left unchecked, this is going to be increasing over time. and I'm going to have a real problem where I have cable insulation meltdown, and quickly that's going to get out of control. Obviously, in a site that's not a controlled environment like ours, this takes time to build up, right? But that's why it's important to be looking at this data, taking samples of it over time, and seeing what it's doing, right?
So,
right here, yeah, go ahead.
This is Duke. I just want to point out to our audience, they can't really see us, but I'm at home and I just got an email that alarm went off. So when we're talking about the power of this, it's not only the ability to see this type of data on the front of a piece of equipment, it's also the ability to dispatch warnings and alerts and alarms to the people who may need to know it the most. So, this is a simple example that we've set up as a demonstration, but I did get an email within about 30 seconds of when that light turned red.
Yeah. So imagine now Duke can dispatch somebody knowing exactly what piece of equipment, which structure, and which phase that person needs to look at, versus having to shut everything down and start troubleshooting where the problem is. Now, this is one quick example of how modern systems take a product, and we like to call this a connected product because it gives us information. It takes the information, provides it to something, in this case a concentrator, which then gives me a notification here on the HMI, and then that data can get propagated quite fast, as you can hear, to a user somewhere within my facility or at their house, and know exactly that something's happening. And all of this is 24/7 immediate notification. Some of the software that we can utilize for this, and again, we're not going to focus on anything, but the importance here is to look at all types of software that can leverage this data and tell me that something is happening or incorrect. Let's kind of relocate a little bit to one of our building management systems. Again, there's several options for this, but we're going to look at one, and I'm going to show you a quick example of how we can leverage data and uncover things that are happening within a facility. So as Ian relocates the camera here, here's a really great example that we like to show to people. So let's focus on this screen up here so that we can share that with everybody. Now, knowing that you have issues is one thing. Uncovering vulnerabilities within a site is worth gold. If you look at this trend up here, every single time that we do one of these tests like we did today, we have this little spike because we just increased the temperature. Look at every single spike. It only happens once a day. Sometimes it's higher, sometimes it's lower. But look quickly at this portion right here, right? This is one of those examples where we came in on Monday and said, hey, somebody didn't shut off something over the weekend. And then it was kind of hard to hide it from our manager because, again, he had it all in front of him. And we were one time showing this to an audience much like today, and then realized, oh, he still hadn't figured it out. But now I guess the cat was out of the bag when we showcased how easy it was to uncover something that could have happened. Okay. Now, I don't know if there's anything here that you'd like to add in, Duke.
No, I mean, I think that's a great explanation, and having this the history of events is obviously important when analyzing the health of a building in any in regards to power quality. I mean, we're obviously talking about temperature right here, but this could be true about any history. So whether it be power quality or energy usage, or any number of factors that play into the health of the building, the ability to have the data and to analyze that data is really a big key here to make this whole thing work. Jim,
right.
Have there been any questions? Do we need to pause here and take questions at all? This might be a good time for that.
I don't see anything in the chat box. I want to remind folks to use the chat box for question entry.
Yeah, so Jaime and I are an open book, so please ask away if you have any questions. But I think this is a great example of tying all of those pieces together, from the connected equipment, Jaime showed you the circuit breakers that are connectable, to the thermal monitors. I mean, in this example, we're showing you a wireless thermal monitoring system, but it could be wired as well. And then the data flow that comes back to a system that's managing the history and the existing historical data, and then to a system that displays that history. So whether that be like what we're looking at here as a power management system, but it could be a building management system. It could be, any system that's able to be integrated to the data. In our case, we're using Modbus data. So everything that you're seeing is simply Modbus register data that's been displayed on some sort of a dashboard. We're going to show you an example in a minute of taking this data and doing some analytics on it, which is pretty interesting. You saw the pump motor earlier with the damage to it, but there's some really really powerful stuff that you can do with this data.
Right now, hey,
let me interrupt.
Yeah, go ahead.
Yeah, there is one question. Some folks are not able to use the chat box, so they're using the question input. First question from Stan is, what has the reception been from the audience, the corporate, facility managers that would be the end users of these features?
Any feature
that we want to focus on? Yeah, so when you talk about the reception, I mean, we get into a lot of discussions around receptiveness of the entire system versus the receptiveness of a specific feature. I brought up the question on purpose earlier on Bluetooth. Would you be willing to accept the Bluetooth control of a circuit breaker? And many of you said no way. And that's a response that we're hearing quite often. The big breaker there in the switchgear, the one with the green front on the front of it, that breaker has the capability of being controlled with a smartphone. And so we have a whole range of, there's no way I'm going to allow this to, I love this because I can stand away from the breaker and do my work. But then when you get to a larger, the bigger picture of just a connected system in general, there's a large proportion of what we sell at Schneider Electric that is connectable. And honestly, our target with Schneider, just to be transparent, is that everything that we sell is connectable in some way. And we've got a lot of initiatives going on right now to include connectivity with everything that we sell in some way, and almost a freemium type offer in some situations. So we see a very, very broad interest in this. When we get into things like thermal monitoring, we see almost a universal interest in that. And you guys were the same on the poll. We saw that the very important to have 24/7 thermal monitoring as being pretty universal amongst even the audience today.
Right. And now, and one of the other things that we're enhancing is, how do we have a more immersive experience with any equipment that we have anywhere in our facility? I want to elaborate on that a little bit. I put this iPad right here in front of everyone where you can see, and you can see what the iPad is showing us. We have now this is where we get into like what I like to call mad scientist kind of information. So I'm going to ask Ian to zoom in here to our feed from the iPad. So the iPad is really just looking at the front of our equipment. But because we have digital and connected architectures, I can quickly be walking in front of my equipment, just point the iPad anywhere and say, hey, what's happening? Look, this is open, this is closed. I can operate something, look at the information, toggle in real time. You can just see that status changed. Or I can actually do, I've never had to touch the equipment. Well, I did to do that, to realize what the status is of something. And this is where it gets fun. I never had to open up any door to know that there's where everything's located inside of that, right? Now, not only that, but I can also have support or somebody come and look at the equipment with me from a remote location, and that person's looking at the same thing that I am. You see this little floating gentleman right here? This gentleman is in a virtual room, and he's looking at the same equipment that I am, And actually, let me put that gentleman on screen right here, where you can see, where did he go?
Huh. And Jaime, while you're doing that, just to explain to the audience a little bit about what we're looking at. This is augmented reality, right?
Yeah, this is augmented reality where we can create a digital twin model for everyone to see all that connectivity, whether it's information as real-time metering, real-time status. Again, that gentleman right there is somebody who's remote, but we can look at temperature data and see the same temperature information for anything that we had in the equipment. So again, leverage digital connected architectures and get creative with it. See what you can do, see how much you can push the envelope. That's what we do every day, and you know, we have fun at doing that. So again, I don't want to get too caught up on this other than saying, you know, the sky's the limit as far as really what you can do anytime that you're looking at any system like this. But it's really easy to just grab your iPhone, your Android phone, iPad, you know, HoloLens, come up and say, here's the status of everything. I'm at a safe distance away. And I never had to figure out if I'm safe, if I'm in an unsafe scenario, because I can tell all the PPE equipment, I can tell the arc flash boundaries, etc. Again, I always tell people, tell me how you want to enhance your equipment and we'll find a way to do it. All right. So,
I mean, we have a question from one of the viewers. Is it possible, I think this is a larger question, but is it possible to utilize parts of Schneider Electric system with other brands? So things like thermal sensing or augmented reality here, or you know, any other data that
so you actually see this gentleman nodding and saying yes. The answer is yes, yeah. because all the information is open, right? Again, that's why it's really important early on to focus on the type of data that you're going to be using. If you're locked into proprietary protocols, guess what? You can't really leverage that info much. But if you're using protocols, for example, like we like to use Modbus, serial Modbus over Ethernet, all of that can be leveraged, shared, and it doesn't matter the vendor. All you need to know is what that data is and extract it and accomplish everything that you're seeing here today for that facility. And the good thing with that is that
I will say specifically, if the question was about the thermal monitoring system that Jaime showed a minute ago, that is a Schneider system which currently is only tested and allowed in Schneider equipment. So that's something very specific. But in general, the whole topic of today of these connected systems, it is very common. It'd probably be extremely unlikely that a system would be totally Schneider Electric. I mean, it's very, very common that you would have multiple vendors providing information into a common monitoring system.
Right, absolutely. Okay. So, I mean, this is a good moment to see if there's any other questions before we move on.
Jaime, another question that came up, and we showed a phase B terminal temperature high reading earlier. And the question was, what could be the root cause of that? And would you still need to power down and open up the cubicle once you have that data?
So a potential root cause of that is that maybe something wasn't torqued right, or it's coming loose over time. So once it actually starts separating, it starts creating resistance, and that creates a hotspot. Do you still need to power down? Absolutely, because I mean, the system will tell you, hey, here's the location exactly where you need to look at. But now you can do this quickly without having to propagate into other different sections. I mean, there's ways now that you can. We would always recommend that you never work on equipment while it's energized. You have to shut everything down. But I know that there are some customers that say, okay, as long as I isolate all my components and areas, they have taken those opportunities. But you know, the matter is, you need to know where the fault is, where the issue is, so that you can put your efforts right there to correct it.
I mean, another perspective of that is the predictive capabilities that we're talking about, right? So just because you got an alert that you have a temperature variance based on what you see versus the expectation, that doesn't mean that you have to fix it today. It means that you're seeing something that's a little bit out of line, but telling you that there might be a problem down the road, right? So that's a very, very important topic here, is that we're giving, in this scenario, you're getting information way ahead of the time before you have a problem. So you might not need to go do the maintenance for another 6 months, but at least you know that there's something going on that needs to be looked at, right? So you think about going to the doctor's office, your cholesterol is going up a little bit. Maybe you don't need to do anything about it yet, but let's keep a very close eye on that.
And Duke, this might be an opportunity to go back to that predictive analytics slide that we introduced earlier in the presentation.
Yeah, let's do that, Jaime. If you could put that slide back up.
I can get again to go from our camera source to our computer source, so that now we can go back to that slide and really discuss that, because that really falls into place to what you were saying. So let's go.
So one of the big kind of a newer capability that we're seeing over the past couple of years is the ability to run analytics on existing data. So when you start collecting all of this great data, and I mentioned this before, everybody can collect data, everybody can store data. We've got huge databases full of data, but what do you do with that data? And I think it's something that we're all learning about these days and getting better and better at it. But whether that be temperature data, or in this case that you're seeing on the screen, it's vibration and harmonics data, being able to look analytically at data and predict into the future becomes a brand new thing that we've not seen up to this date at a big scale. This particular example that we showed you earlier is predictive analysis on a rotating pump. So it's a mechanical pump. You can clearly see that it's failing. It's been cavitating. It's very, very close to the point of failure. That fault, or that damage, was able to be seen on the graph at the lower left by looking at a combination of harmonic data and vibration. And by doing some analysis on that over time, we can see that there's degradation happening and that this thing's about to fail. Now, how valuable is it to be able to say, you've got a pump that's buried in the ground somewhere, it's failing, we need to go get it fixed at a appropriate time, versus waiting until it fails and then we've got an emergency outage. So whether that be, again, this is a mechanical pump, but that could also be a joint, like we talked about, a joint getting hot, we're seeing a temperature rise. It could be harmonics inside the building, and so we're seeing propagation of harmonics that's growing in our building. We're getting to the potential point of having damage. All of those things, being able to see that in the future now becomes an extremely powerful part of collecting data in a connected system. And back to that actionable data, doing something with the data that helps you alleviate downtime and makes your building more reliable, especially when we get into critical applications. So any of you that work in critical systems know that all the backup systems and all that go into that is extremely important. And then when you can layer on predictive analytics on top of that, it becomes an even better or more powerful way to manage a building and to manage that data. So we just wanted to show you this as an example kind of what we've been talking about today, of what happens when you collect all the data and what does that actually give you at the end of the day.
Right, where can you get to by having a digital connected network system looking at the data and really telling you what your facility is. I mean, really listening to your facility and saying, hey, I have a problem. My arm's starting to hurt. I need to do something about it. Okay.
Yep.
So I guess from our standpoint, we wanted to go through the story of showing you a connected network, show you what our facility, and just going through the story of how do we really design with the outcomes that we want to do, right? What are the considerations? What are the key elements that we're trying to reach? And from everything from a product, which is a meter, a breaker, a relay, an actuator that's giving me information, how do I take that? How do I process that so that I can take it to the next level and really hear what my facility is operating under? Okay. So,
we had a quick question from the audience on protocols, and the question was, are there other protocols used by this equipment in addition to Modbus? The answer to that is,
Yeah.
is yes. There are many protocols. You know, Schneider Electric, just in general, we focus on Modbus heavily, but there's you know any number of other protocols out there. You know that breaker that they're the breaker.
We can talk. You know,
you see there is
Ion, BACnet, Profibus. What was it?
IEC61850.
IEC61850. And most of them are open. Some of them are proprietary, so you have to be really careful about that too. Okay?
Yep.
So that's actually a good question,
so
because that's the type of stuff that you can think about.
Okay, so we were going to run over to microgrid real quick as well, Jaime, right?
Well, I didn't. Let's go. So let's put the slide back up, Ian, so that we can relocate without tripping over some cables here. And so let's go over to our Energy Control Center. And here we go. So this is our Energy Control Center. Yeah.
So go ahead, Jaime.
No, please.
Okay, so sorry guys, we this is a little bit weird for us to be in different locations today, so sorry we're stumbling over each other. Just talking about microgrid really quick. I know we're about out of time, but we just want to introduce this topic very briefly. Regarding microgrid and kind of what that is, what it does, and one way to approach that. So when we talk about microgrids, usually it's discussing multiple power sources, alternative power sources, often known as distributed energy resources, so DERs. And in the world of microgrids, there's a number of different DERs. It could be solar, it could be wind, it could be generator. There's a number of other alternative energy sources that can be utilized, and then a microgrid can be, both part of the power grid. So it could be a small section of a larger power grid, but it also could be a smaller section of like a building. So what we see in many of the applications that we're seeing is a microgrid that's part of a larger building. So think of a automotive manufacturing plant, and in part of their plant, they want to assure that there's always power available to that if there should be a major outage. So they may have a generator or a solar field or something like that they want to run that part of the building off of. So in this particular case that we're showing you here, we have a couple loads set up, and we have multiple power sources. So that could be main power coming in from the utility. There's a generator available here. There's solar available here, and there's also a battery backup. So now what happens is that if there was a power outage, this particular piece of equipment that you're looking at can actually go on islanding mode. So it can separate itself off of the power grid, and it could run standalone off of a generator or other means of power generation. So there's some logic set up that says, hey, if the utility drops out, let's go to generator. If the battery is available, let's supplement the generator with the battery, or solar rather. If solar is available, let's utilize solar along with the generator to supplement it. If we're at night and there is no solar and we're in a heavy load situation, let's utilize battery backup to supplement the generator. And then if the battery runs out, then let's do some load shedding and drop off our non-critical loads and keep our critical loads on the generator. So there's a lot of logic that can be built into this, but essentially what it does is it utilizes power in the most effective way possible. So both from an efficiency standpoint and a reliability standpoint. You may not know this, but many solar fields require utility power to exist. So you have a grid forming and a grid following version of solar. And most solar that we see are grid following, meaning that they're putting power back out onto the grid. So if the grid isn't working, if the power is out from the utility, then the solar field's doing nothing. Then you also have grid forming, which is where if the utility drops power, then you can separate from the utility and you can form your own reference point, which is the way this unit that we're looking at works, where the generator can be the grid forming resource, the anchor resource, and everything else can run off of that, and it can run on an islanded mode. So that's a couple different interesting ways of looking at that. But then we go back to talking about data. We talked about data today, the whole day, of having connected devices and intelligent data about a building then can roll into this type of logic that says we have the data, we know that we know things like that there's a storm coming, so there's a weather service that can predict you know, the likelihood of you having a power outage is greater than X%. Let's start up your generators, let's go on island mode, let's get off of the utility, and let's make sure that this critical facility has no possibility of going down, so you know, a hospital or whatever. So having that connected data could go everywhere from a weather forecasting service all the way to analyzing something like a pump failure because of cavitation. So there's a huge broad spectrum of what can be done when you have connected data and the ability to see all this information at the same time. All right, I know we're about out of time. We've gone a little bit over. Are there any other questions that that you all might have? Hopefully, we've covered the topic a little bit today and shown you what a modern connected system looks like. Apologize for the rough me and Jaime not being together today, but hopefully we were able to get across the message of you know, what a power system looks like these days when you start putting all this technology together and seeing how it works.
Duke and Jaime, I think you did a great job of presenting a fascinating topic, and there will be a survey at the end of the webinar for people to either ask additional questions or ask for contact or additional information from Schneider. So I wanted to thank you both for contributing to our webinar series, and we look forward to working with you down the road. So long.
All right, thanks very much, Jim. Have a good day, everybody.
Thank you, everybody.